Okay, great. So a few things I wanted to cover from last class was the extend tool. So the extend tool, let's just draw a line for an example. Extend tool functions just like AutoCAD, if any of you are familiar with AutoCAD, but it is spelled out exactly how you say extend. We select our border. So select our boundary objects or enter an extension length. For this example, we wanted to extend this line to this boundary. So it's really simple that we just select this line, enter, and then we can select our curve, and it will move to that boundary. We also have the fillet command, which works, again, very, very similar to AutoCAD. Let's just copy this over. We can fillet, and it's going to ask for a radius, or it's going to ask for a first curve and our radius, join or trim. Typically, we just will select our radius, which we can have as, let's make it 4 inches. And it will give us a nice little 4-inch radius at the intersection. We can also use the fillet tool to clean up a few edges. So let's say we just want a nice clean edge here. A good tip is fillet and set the radius to 0. And when we do that, that cleans up that edge. So just a few quick 2D line, 2D tips that are used quite a bit that I found very helpful. But let's say we have a curve, pretty complex curve. And we're going to switch the top view. We have another curve here. Well, I want to join these curves, and I want to have that same organic form that it has. So there's a great tool called Blend Curve. And what we do, we select our curves to blend, and it will interpolate that curve so we can make it, so we can blend these two together. And we can also start to adjust these manually if we really want to, or we have options here as well that we can start to manipulate. And then these give us some options too if we want to join it or trim it. And typically we want to, let's say in this, we want to join it. We'll click OK, and it joins it into one line, into one nerve, or into one curve. And we can start to manipulate some of these control points. But let's say I have this curve here. We're gonna, and this is at our top view. We're gonna make another curve on our front view. It's almost like we could say that we have an elevation view and a plan view of an object, and we want the 3D curve of this. So there's a great tool called Curve to View. What that does is it interpolates the two curves at the two different planes. So we'll click this one, click that one, and it interprets a curve in 3D for this. So again, it's just, these are great little tools just to get yourselves familiar with some really organic boundaries. And from here, we can start to create some really organic forms and curves and surfaces. But they're all great tools, especially when you're 3D modeling something and someone's given you just a plan view and an elevation. You can trace those or draw them up, and you can use this tool to help get a three-dimensional object from it. So one other thing, I think I might have mentioned this one before, but this one is really important, is the explode. So if we have let's grab a box really quick. So the tricky thing about Rhino, that if you guys are familiar with SketchUp or AutoCAD, is the center mouse button. If you're using a mouse, brings up a quick menu. This quick menu is great because it has a lot of the tools that we use the most with our display, our join, some view extents, our save and locking and unlocking objects, even some rendering options. But it also is explode, which is a fantastic tool. So if I have this box and I really just want these two faces, I can either type explode, or I can use my center mouse click to explode it, and it breaks it up into the 6 ISO or 6 B-reps. And so then I can highlight them or hold shift to highlight 2 of them. I can join that, and I can start to get rid of the rest if I just wanted those 2 curves or those 2 surfaces. We also have let's say we start to get into 3D and we want to go back to just to line work, to 3D line work. There's a command called dupe edge. Now dupe edge allows us to start to duplicate some edges from 3D objects. So we can start to select some of these edges. Enter, and it actually draws a 2D line. We're going to hide the surfaces. So this is really helpful when you start, if you just if you were given a complex form and you wanted to start to deconstruct it and start to get 2D line work or 3D line work from it, you're able to do that. You can also start to just extract wireframe, which is another, but this one, that just absolutely just takes everything and makes it into a 2D shape. Now this one you might have to be careful because it does duplicate your ISO curves. So, which in some cases is good if you want the ISO curve. Now remember the ISO curve always points through the center of the plane, center of the surface. So in some cases where the center is really important and you want to start referencing the center of things for 3D modeling, that could be a great tool to have. And also, if we have just a planar surface, and let's say I just want this boundary. I don't need the surface. I just want the curves. I can type in dupe border. And I can select my surface and press enter. And that generates the boundary of this, of the surface that I want. So these are just, again, some good just little tools to start to break down objects. And then some of the last ones are scale. So there in Rhino, there's 3 different kinds of scales. So I can just do the normal scale, which I believe we talked about last class, which scales the object uniformly. We can also scale it in one direction. So if I do scale, and if I just in mid-typing just type SCA, it gives me a few options. So I can do scale 1D or scale 2D. So it essentially means I'm scaling it in one direction. So here's my base point, and it operates just like the normal scale uniformly, but it just scales it in one direction. Now, if we have a 3D object, and I really like the height of this, but I want to expand it in the X and Y direction. I can use scale 2D, which means we're going to scale it in 2 directions. And it operates the same way as all the other scales, and it can operate in that. I can also set my reference point. If I want this, I can set a scale factor. So I can say I can do times it by, scale it by 2, or I can set this to a certain dimension. So if this is, let's do it at 250 feet, it will scale it so this edge is 250 feet. And we can grab a distance and we can measure it, 250 feet. So a lot of those are great. I particularly use a lot of the scale 1 dimension because, especially if I have a mullion or something, let's say, let's grab a box really quick. So if I have a mullion that I scaled it and I extruded it, but it's just, I was just shy of something. I was like, man, I really need to get down here. You can just do a quick scale 1D, click that, click my point, and just drag it right down to the end. And it's just, instead of redrawing this and re-extruding it, for me, it can be a quick time saver. So when we start getting into NURBS, start with a simple plane. So over here on our left side, we have this surface from 3 or 4 corners. We also have this little triangle here. We can click that, and that gives us a lot of options of how to generate surfaces, either from 3 to 4 points. We can create it from just a rectangular plane, or reference 3 points, or vertical, or we can have a plane, create a plane that's through all these multiple points. But probably one of the most basic ones is just a rectangular plane. And before we even click any points, it gives us a few options. It gives us 3 points, vertical, corner, around the curve, and deformable. Probably the one that is most interesting we're going to cover is deformable. And we can either hit D, or we actually can hover and click this. Now it's going to give us options. And we want to keep these kind of degrees of 3. That's usually standard. That's we don't need to get into much of those, but really what we're interested in, the U point count and the V point count. So for when we 3D model stuff in Rhino, we always use an XY coordinate system. But for surfaces use a UV coordinate system. And in this one, what it's saying is it's going to divide this plane into 10 by 10 points. And we can always adjust this, so it could be a 10 by 25 or 10 by 15. And when we do that, it doesn't matter how big we make this plane, it's going to be divided up by that amount. So when we, in our perspective view with the display, which doesn't show any ISO curves, we won't see it. And we can always turn on the ISO curves. But in our wire view, we see our ISO curves. And actually when we highlight it, we see it as well. what we can do is the next tool we can do is highlight this, and we can type in points on. What points on does is it shows the surface, the points that dictate what a NURB surface, or the control points of the NURB surface. So then we can start to select some of these points, and we just start to see the plane being deformed. We actually start to sculpt the behavior of this. We also select multiple ones, and we can start generating that. And the important thing is with the NURB surface is that these points are not dependent. As I affect one, it's going to start to affect all the others, or it will start to affect the surface. It won't affect the point location, but it will deform the surface. So we can even start to sculpt on how this thing starts to look. We can start bending this corner down if we need to. Or if we really just need a simple, let's say maybe we don't need this. Maybe this was like, all right, we don't need an organic form, but we really just need a simple 2D surface. Something just like what SketchUp is, where I can just draw a few points and it creates a surface. And that is our point 3 and 4, which is usually the default right here, or we can type in surface it's just surface point, which then will ask for our 3 or 4. And those can just be any points, and it creates that, or it can be 3 points. But that doesn't have the option of the deformable. This is what you typically call a BREP. It's a boundary representative surface. So it's just a surface that's just defined by these edges. While this surface is more of a NURB surface where we can start to deform it through, it's generated through points, and we can manipulate the points, and the surface works with that. Let's get into even some of the 2D commands that we have, like the fillet command and the extend command are also, we can use these for surfaces as well. So if we have let's just do a simple line. And we'll use the gumball to extrude that up. We'll get another line. We'll get a polyline. And we'll start to we'll extrude that up. Extrude the same height as this. So if I wanted to extend these, I can actually have an extend surface, and it's going to ask me an edge to extend by. So we're going to select that edge. We actually select it, and we actually, based off, we can actually set a few an actual length, just like the other one. Bumps it out 100 feet. We can also do a fillet surface. A the radius of, we can set any radius. In fact, we can set the radius 0 if we want these to meet up. Maybe it doesn't work. Oh, maybe these have to be. These up for the fillet. Do our radius of So one thing about the fillets and the extend sometimes is that they sometimes have to be in perfect plane with each other for it to work. That's weird. So sometimes these things have to be that sensitive. Or it might be not a simple plane neutral. Huh. But this usually generates a surface that we can, that it usually generates a surface that's based off the curve of the fillet. And that can be really helpful if we just want, if we have like a handrail or something, or just something that has a nice curve to it. Yeah, there we go. Delete that. So it creates this nice little edge if we just to keep things a little cleaner if we just want some little detailing around it. Also, get something a little bigger on there as well. Again, a lot of the same options that we have for curves are also for surfaces, so even offset surface is one. Actually start to select a few of them. Now, sometimes it's going to ask for a flip direction. Actually, these are all going the right way. So all right, it's pointing out this way, which is good. Which gets me to another thing I'm going to talk about, which is normals. So let's just offset this by 50 feet. We'll flip it. And it gives it some nice thickness here. So it's great for just if we want to add some thickness to things, and like a steel column or something, we can do that. One important thing is normals. And normals is it's tough. Let's see if it's kind of tough to explain, but it's when it's really evident in SketchUp. So when you 3D model things, it reads objects in a certain order. So if I drew this, the programming of the programming of Rhino and most 3D printing softwares, it will create this surface and it will read it as 0.1, 0.2, 0.3, and 0.4. And it'll read it in a specific order. And so in the right way, the normal is correct when it generates a surface in the correct order. But sometimes the way we create 3D models, we may create things in a backwards order. So it will be, and I believe the normal is counterclockwise. So you always want to model stuff counterclockwise. But if you go clockwise, you can get your normal flipped. And it's not a big deal. That's why SketchUp, a lot of times you'll have a darker side and a clean white side. And sometimes when you're looking at your model, you're like, gosh, why are some panels this blue color and others are white? Was because the normals are flipped. The software is reading the planes in a different order than it's supposed to. It isn't a big deal for 3D modeling. However, it is a big deal when you start to 3D render things, because those maps that you use for 3D rendering, those bitmaps, are all referencing a UVW coordinates on that surface. So when the coordinates are flipped, the map is flipped, so it won't render correctly. So for this class, it's not a big deal. It's still, the software is sophisticated enough for 3D printing that if you have flipped normals, it will still register that, hey, this is a flipped normal. But I can still, I get what you're doing. It's a surface. It's just 3D rendering software has a tough time with it. In all my time 3D printing, I've never had, it was all the software that I've dealt with was smart enough to be like, hey, this is a flip normal. It's not really an issue, but just to give you a heads up, it's a flip normal. But if the normal is flipped, then there's a very simple command called flip, and it flips it. In this case, it flipped the direction of one object. And for this, Rhino's pretty good at, and we'll get into that 3D printing of how to deal with it. The nice thing is, normals are more for meshes, and so far everything I've showed you has been, it's been BRUPS, which deals with normals, but a lot of the NURBS don't deal with normals. They're usually generated correctly. But just something to keep in mind. We'll dive deeper into that in later modules. But just something to give you a heads up. But let's start making some cooler shapes. So let's delete this. So there's a great tool, just like, let's do a loft. Now I think some of you guys may remember loft. We're gonna create some curves really quick. Oh, draw one more. Why not? Make it complicated. So we got these three curves. Let's start moving them around. So loft is what it's going to do. It's going to generate a surface that interpolates these three surfaces. And the way we click on these curves are really important. So it matters that we click this because it's going to read this surface first, this surface second, and this surface third. Click enter, and it generates that surface. Now we can also start to rebuild this, and we can start to get into how to redistribute some of the control points of this surface. So we can always refit to a certain degree of inches, or we can control it with control points. We can also change the logic of how it's lofted. So we can make it more of a real loose form, we can get it real tight, or we could just do a simple straight section, which is not as smooth and nice, but it gives us some options that we can start to deal with. Sometimes, we're going to flip this. Sometimes, just very similar to normals, a curve is generated from a certain logic too. So if this was 0.1, or this is a 1 point, and this is a 2 point, the other one might be made from a 2 point to a 1 point. And that sometimes is an issue, because if we flip that surface, we get this kink, which is not what we want. We want to go back to what we originally had. So what we can do is with two options. We can exit out of this, and we can just type in flip, and it flips it in the correct direction. We can reloft this, and it gets back to normal. Or we can fix it in the loft command. Well, let's say we can, let's say these are not correct. We can always do an align curve. And what that does is we can change the logic of how it generates the surface. So let's say we did want that kink. When we click on it, it reverses the order of the curve, and we can start to get the kink back. And we can click it again, and it reverses. Or we move this one, it will reverse. And so on. And then we can start to change some of the logic. It's not good practice. I mean, we typically want to avoid stuff like this, because it is impossible to 3D print, because this one surface is infinitely thin. So things need to be print with a specific thickness. And when it does that, it's like, I don't know how to create that with something that's infinitely thin that self-intersects like that. So it's usually not a good form, and we don't really want to have that. So we keep our forms as that. Something clean. And then when we're done, when we like our surface, we can just click OK. And there it is. And now it generates a surface, but it keeps our 2D lines. So we're going to create a new layer. We'll just say our 2D lines. And we're going to highlight these. We'll go on 2D lines, and we're going to turn those off for now. Let's cut a rectangle out of this. So we're going to get, so as I mentioned from the first module, Rhino uses viewports to cut its geometry. We don't actually have to intersect this object to cut it. So what we can do is we'll grab our rectangle tool, and we'll just cut. Say we just want, let's say design-wise, it's like, this feels a little too flat. I want a real special element to happen here. So what I can do is I'm just gonna take this. I'm gonna cut this surface. I'm gonna do split. I'm going to split the surface, click enter, and it's going to ask for my cutting object. Select that cutting object. And there it is. We just cut our object. And see, with the split command, and when we're in the top view, it will do a direct 2D cut on that. So let's just hide this for a second. And we can do that by just typing hide. Hide, it'll ask for an object to hide. We select it, press enter, it goes away. Now it's not deleted. We can bring it back by just typing show, and it comes back. But hide is just a great way. It's like, I'm not ready to put this on a layer. I'm still editing things. I just want to hide it temporarily. So we want this boundary to be a feature. So we're going to make this curve. I think that curve would be nice right there. We're gonna use some of the control points to start to manipulate this curve a little bit. We're gonna make it even 3D. We're gonna have it pop up. Since this is the low point, we want to make this an element. We're gonna bring this form up pretty high, and we don't want to dip it too low. So we'll have something like that. Something like this. We'll just start to sculpt this thing. So we got this form. We're going to use this curve and this boundary to generate a surface based off this. So we're going to use this command called patch. What patch is looking for curves, points, point clouds, or meshes, and it's going to generate a surface that fits within these boundaries. So we're going to grab, and it's important when we do this, when we type in patch, it's going to read our 2D curve. We want to make sure that doesn't happen. So we're actually going to hide that as well. Let's do patch again. We're going to select that curve, this boundary edge, that boundary edge, and we're going to select this curve. We're going to click space. It's going to give us this command, and it's going to, just like how with the plane with the deformable, we can start to define this as a UV direction, how the surface is going to divide it up. Now, the more times we divide it up, the more tight it's going to get. The less we divide it up, the more looser it's going to get and less defined. And we also have an auto trim, which is usually pretty good because I'll just show you. So we're going to preview it. It's going to generate the surface that fits within this. It's set to auto trim because if we don't auto trim it, it's going to draw the rest of the NURB logic of the surface. We don't really need that rest of the logic because we're going to just have it match up with this surface. Now this NURB logic, all of this large swoopiness is not going to go away. It's still this surface needs that for it to exist. But what it's doing is it's just like, okay, we're going to trim the surface. The points that define this object is still going to be there. When you use points on, it's going to appear, but just the surface will trim it and get rid of it. We can also set this to be tighter if we need to, and we can always set these and we can preview it. So it gets a little tighter if we need it. Or we can get things really loose and start go to 10. So we can start to click OK. And we start to now have this object that has this element to it. Patch is a really powerful tool. Patch is fantastic for a lot of times in architecture. We work with civil engineers, and we get our topography maps. And topography maps are especially difficult to 3D model because they're so organic. And there are programs out there that do a pretty good job of it. There's also programs that are like SketchUp. SketchUp has a topography tool that helps. But this one is definitely the best that I've seen. Now, one reason why we want to use a patch and not a loft is because a loft requires all the curves to be the same. So if you want to loft something, it can either be all closed curves or all open curves. You can't generate a surface through loft with a mixture of the two. However, patch, you can. And that's why patch is so powerful, because I may not even have all the information from the survey, but I can start to, I can still generate a pretty close, pretty accurate, oh my gosh, that's 15. I'm gonna scale this down a little bit. This is huge. I'm gonna scale this down to it. We also use fractions too if we want to for scale. So I'm just gonna scale it. Start to get this closer. So we'll scale this by 5 feet. Scale this by, start here. Sometimes topography maps have spot elevations, so, and they didn't finish drawing the contour line, so we'll draw a point here. Yeah, and so we'll set this one at 175. We'll also have a weird anomaly here that, you know, they just ran out of time, didn't have a topography, so we'll make this one 100. But what we can do is we can, the nice thing is patch takes all that, and it doesn't matter what order that we pick it out of. Click enter. We'll make this out of 25. Out of 25. And it starts to generate a surface from that. And we'll turn off auto trim because sometimes it gets confused with some of the B-reps. There it is. So there, we start to get our surface and all our topography. So let's hide some of this stuff. And let's pretend, you know, we have some sidewalks and roads or some other stuff that we want to introduce. We have this really nice curvy sidewalk. Sidewalk. Offset the sidewalk. We're gonna make it big. We got this nice little sidewalk that goes up around. In this case, we don't want to say we don't want this curve to cut this. You know, we just want this curve to follow the curvature of this surface. So there's a great command called project. So what it's doing is it's going to ask for us to select some curves or points. So we're going to select our curves, press enter, and it's going to ask us our surface that we want to take the curves and project it on. And another important thing is direction. What direction do you want this thing to project on? Which is really important because if you want to project this on the X direction or the Y direction, most of the time we do it on the Z direction, we're projecting something down, but in some cases we want to project in a different direction. We have that option. And we can also put it on different layers if the output of that is different layer, because like typical Rhino commands, it's not going to delete these curves, it's just going to create a new one. Oops. So we'll project, select the curves, we'll select the surface, and there we go. Now what it did was it took that curve and it projected it onto the surface. So actually the curve follows the topography of this. So, and let's say we don't need, let's just say we just want it. And there's our surface right there. Or if we want to just, now let's say we didn't even need that topography. We just really wanted to see that sidewalk. We could actually now just do a loft. And we can loft these two together. And we'll make this normal. And see, sometimes it doesn't get, see, sometimes it interpolates. It's a little tough to see on my background. Hold on. Sometimes we start to see that curve and it's not following exactly the way we want it to, because it's following this. It's gonna generate the surface based off 10 control points. Well, yeah, it did that, but we're gonna need more control points to really get this accurate the way we want it to. So there's an option we can refit, and it refits this based off this degree of inches. That's pretty dang good of how it refits. We also rebuild it and just add a lot of control points as well. So we can always add 100 and 100, and we get that, and it generates that pretty close too. So we'll just do refit really quick. So we have this really meandering surface, or this pretty wild surface. It's pretty complex. So we're gonna go back. Show this again. We're gonna delete this surface, and we're gonna delete these curves. Let's say now I really just want to create a sidewalk here, and we're actually going to make a new layer. We're going to call it 3D grade. We're going to change the color of that. Change it something like that. And we'll also have another one called 3D sidewalk. And we'll make that into a dark gray. So what if we do want a little sidewalk here and cut through that topo? Well, we can just use that split command. We'll select the object that wants to get split and our sidewalk that's cutting it. And there it is. So just like the project, it cuts that. And we're just gonna change that object layer to there. And there we go. We have our little sidewalk that's cut right through into our topography surface. So let's say, delete this. We're going to do another. Actually, does anyone have any questions? Am I going a little too fast, or are we doing pretty good? Okay, cool. So let's say we got two complicated surfaces. In fact, you know what? We're going to reference this, guys. Let's draw another surface here. We'll set to our default. Good. It's over. let's say I want to continue this idea, and I generated another surface that I really like, and I want, just like the blend curve, I want to create a surface that just blends these two together, that interprets these two patterns, and just gives me a nice blend. And just like a lot of the curve commands, there's a surface command for that. So there's a blend surface. This time it's looking for a surface edge. So what we're going to do is we're going to select this surface edge here. And then it comes up, select second edge. We're going to select this second edge. Ooh, that was not a nice surface. So in this case, I believe the normals are flipped on this one, because this is nasty. So yeah, definitely the normals are flipped on that one. So we're gonna flip. Let's see if this works again. Let's see if it helps.
I have a question.
Yeah.
When you were doing the projection of the sidewalk, let's say we had some topo and we wanted to project, say, the street scape. Would you be able to show us like recessing the road?
Oh yeah, that's a great comment and question. Yeah, actually, we have our own 3D rendering guy, and this is what when we first got Rhino introduced to the firm, I was showing him how easy it is to get a curb and actual road into this. So let's actually let's hit that a little further before let's actually draw our road. This is just a gentle road here. By just our scale so out of whack. We're gonna split, same thing. We're just gonna split this with these two curves, and there's our profile of our road. We're actually just gonna do 3D. We can actually change that to a different layer, and we actually can move this down. And since the scale's all whacked up, we'll just move it down like that. So we have a little bit of our, so right now we don't have our curb though. So what we can do is we can do a loft. And loft can also pick, it can pick curves, but it can also pick surface edges. So one thing we can do is we can loft these surface edges. I'm gonna hide this too. Loft. We're gonna select that curve. We're gonna select this one. There's one curve. But I would say we're not quite done yet, because almost every road has a curb to it. So one way we can do this is we could select this surface and we can offset surface. It's important to watch the directions because, all right, we don't want to encroach into the road. We want to go out, or we can have it either way, but we'll flip it out. So with that, that's just a simple, in the options here, we can say flip, and it flips there. We can also offset the surface both sides. So that means when we offset it, 6 inches, it's also going to offset it 6 inches on the other side. We also make sure it's a solid. So that's really important if we want to start to 3D print this later. And also if we have edges, we can round those, or corners, we can round them, which is really nice because most of the, especially when you're doing parking lots or something, it's really nice to have a nice little round edges. You don't see these sharp edges in reality. So we'll just keep this, yeah, I think all that looks good. So we'll do our distance though. We'll try 25 feet since our scale's so out of whack. And we'll press enter and offset there. Sometimes this happens. We can always go into top view and we can split. And we can use that surface as a reference to split. And it cuts, sometimes it cuts it. That one didn't happen. Let's try it again, split. Sometimes this gets a little finicky when it's surface to surface. It's usually really good, yeah. So this is where it's nice, where it works. Sometimes when you use the split and it's trying to split a surface with a surface, it's a hit or miss. Sometimes I've had some mixed luck with it. Sometimes it works phenomenal, other times like this one, it doesn't. And that's usually where I reference a lot of those edges. So if we do like a dupe edge, and we can just select that corner, and it's going to say it'll recognize that. We'll create a corner out of it. Sometimes like this, if it doesn't extend, this is probably why it's not cutting, because this doesn't have a full cut to it. It doesn't go all the way through the surface, so it's not cutting all the way through. So we just want to extend that a little bit over there. All right, especially here, we just want to extend that a little past the surface there. Now we'll split. Oops. There we go. Start to get this surface out of the way. And we have our nice little curve that goes around there. So that's a great question. That happens a lot, especially with 3D renderings, or if you just want to make a really nice, 3D model. Does that help, Ruby?
Yes.
Great. Let me know if you guys have any more questions. I feel like I'm going a little fast, but if let me know if I need to slow down. So let's create some more. Oh yeah, let's do the blend surface again. So let's go. Where am I? Back here again. So let's create it. In fact, I'll just do this pretty quick. So we'll grab that, move this over. We'll click that for gumbo. We'll click that ball, and we'll say 350. Just click and drag it. All right, we just get a nice simple surface here. Let's just get this going. So if we want to blend these two together, we'll do blend surface. Okay, good. I want to make sure there isn't a curve there. I think it doesn't quite matter if there's a curve there or not. It still does the same thing. Surface. Ooh, it really does not like this. Sometimes when you make too much of a complicated surface, it gets pretty wacky. So I'll move this back further. Or there we go. Yeah, sometimes the surface is just so complicated, it just becomes a big ball. But we can start to blend these into one large sweeping thing. And we can start to, again, just like the blend curve, we can start to manipulate this manually, or we can use the menu here to help us out, just to ease up some of this. Or if we really want something swooping, we can start to generate some really wild forms. Gives us a few options here too. Yeah, that there's some really great little tools that we can work on that can help really work out on some things. A lot of times the blend surface is great too when you just, instead of this extreme, if you just have like a little gap in the surface. I mean, going back to this, we could have done a blend surface. We could have done a blend surface for this as well instead of a loft. All depends on what we really want to do, but blend surface is also great just to, if you have if you just have a gap between two surfaces and you're like, man, I just don't want just a straight connection to this. I want this to feel like it's just a natural connection. A blend surface is a really great tool, especially if you just want to join the surfaces together, and that's what we can do here. We can join these surfaces together, and they can act as one surface. And so sometimes you got to be careful when you do that, because it will put it all on a layer, because that's how the program works. It can't have multiple layers under one layer. I mean, we can do that. That's a sub layer, but this is a little more of a different logic than that. However, the important thing though is this curve here, I won't be able to join that with any of these curves because it doesn't have any open edges, or what we call naked edges, for it to join. It's a solid object. So there's nothing for it to connect because it's already enclosed. So for that to happen, we would have to explode this curve and then rejoin everything together, which is essentially what we're just going to, it's essentially doing this, where we're just making sure that the edge of this surface and the edge of this surface meet up, and then click join, and then it creates a mesh, or still a surface, but it's just a good little tool if you want to deal with these big surfaces. It's actually really important later on when we want to start to get things watertight. It's also good, just a good modeling technique. Keep things simple as that they're joined when they're supposed to be joined or common. So let's make some more cool shapes. So another great command is sweep. Sweep is fantastic when you have a lot, like it's great for just hand railings or guardrails, all sorts of stuff like that. Let's grab this. Let's go get this tool. We're gonna make a. There we go. So So this is the great thing about the quad screen with Rhino is, see on this, when we're on the front view, it's really hard for me to tell where the line begins and where it ends. But with a front view, it's really easy. So I can pick my shape if I want an ellipse, and I can click on that beginning, and I can just drag it right over to my front view, and I know exactly where I'm going to start. And I can start to get my ellipse, and we're going to see that, well, that is at a really wacky angle. So sometimes when it does this, it's not really, we're like, what the heck? It looks great on my front view, but it's not looking so hot on my flat view. So there's a command that helps us fix that. So if any of you are familiar with flatten in AutoCAD, this is flatten on steroids. It's a great point. It's a great tool called Set Point. And what it's going to do is it's going to take all the points that we have highlighted, and it's going to justify them to a certain coordinates. So right now our coordinates right now is Z and X. So we probably want to set these to the Y. And we're going to align it to our world. And we're going to click OK. And it's going to ask us location for points. And we're just going to say 0, 0, and it took it all and it adjusted it to the zero of the Y. So the great thing is then on our top it looks flat like what we wanted, and on our front it looks the correct way. And we're just going to take the center snap, and we're just going to grab the center of that. We're going to justify it right back to where it was. There it is. That's important for this next tool because it's going to generate a surface based off these two curves. So what the command that we're going to do is sweep 1. So the first thing is asking for a rail. This curve, this long curve, is what we're going to consider a rail. When we click that, it's going to ask for a cross section. This is our cross section. So think of it as taking a shape. We're going to take that shape and we're going to extrude it along a path. We're going to take that, and I'm going to change the color. It's difficult to see that yellow. Switch it to my perspective. Right, click enter. We can get this going. There we go. So it's asking us to drag our seam point to adjust. That's very similar to loft. If we have some of our normals or the order of which this cross section is drawn, we can adjust that if we need to. In this case, it's an ellipse, so it's pretty simple. But we're going to click OK. Yeah, it works. And just like the loft, it's going to give us this, and it has very similar. We can have it free form, road-like, which is sometimes it's just different logic of how it's created. We can set an axis to help deform it if we need to. It needs to bow a little bit. We can refit. So refits just like how very similar to the previous example with the sidewalk. You know, it just wasn't perfectly fitting in with our curves. We can have it to refit. when you refit it, it becomes a B-rep, not a NURB surface, so you won't be able to later on manipulate it and turn on the points and start to pull it. It's defined by that boundary. But same with this, we can rebuild it, and it can be defined by control points, which we can later on manipulate. So it's all about how much you want to, the freedom of how much you want to manipulate this thing later on. And so we can see when we rebuild it with a 5-point cross section, it's, we lose some of its shape. So we can either refit it, which then we won't be able to, I don't believe we could be able to fit it or be able to manipulate it. I think it becomes a B-rep when we do this. But we can start to, this becomes more of a NURB when we do rebuild. So we'll bring that up to 25. And we get something like that. That's cool. We start to get a really organic shape like that, which is pretty cool, I guess. Yeah. But we can also, so let's go back to, we can also delete this guy. We can also start to define this. We can also start to create shapes based off. Just gonna, copy this rotate. We got this little wacky shape here. We're going to, maybe this time we won't do a closed shape. We'll do an open one. And make like this little, like an M. See, sometimes this happens again. You're just like, oh man, why did that happen? Let's just do set points. This time it's in the Z direction. That's kind of wacky. There it goes. Oops. Set this back. So what sweep 2 does, sweep 2 is going to take our cross section, and instead of extruding that cross section through a path, it's going to extrude it based off 2 paths. So let's do sweep 2. Let's sweep 2. So it's going to ask us to select our first rail. So these are, we'll consider these are rails. So we'll click this one. We'll click our second rail. And now it's asking us to select our cross section. We'll click that as well. We'll press enter. And it starts to create a really wild form where it's extruding along those curves. It gives us a pretty wild arch. And the same options are applied here. We can start to rebuild it, and we notice that it actually loses when we switch it to more of a rebuild with control points, where it's a NURB surface. We lose that angular because it's all based off points and interpretation of the point coordinates. Or we can do not change the cross section, and it becomes just more of an extrusion. Let's keep it more like organic like that. But we can start to generate some pretty wild shapes like this. And later on, we can actually, points on, we can later on actually start to manipulate some of these points. As we go. Start to sculpt this thing a little bit more. Stop. But yeah, we can start to make some pretty wild organic shapes that we can then later 3D print. And also I'll show you how we can get some of these really organic shapes, actually how we can put these into documentation and start to construct these as part of building elements and actually pass this off to a contractor or fabricator to start to fabricate these things, which that's maybe later on, because that's where Grasshopper really comes in. But let's say we do want to document this guy really quick. Let's say I got this, you're really happy with this form and you just want to get some 2D elevations of it. So that's, or you just have this elevation that you want to show, but we're in 3D. This is a really complex form that would be really hard to trace and very time consuming to do. We also have the plan view. So if I want to quickly generate a plan view of this and an elevation, what we can do is we can highlight it. We can make 2D. What this does is it actually, we're going to make it technical. So the display styles do sometimes matter when we do a make 2D. I'll explain when we highlight this and make 2D. It's first of all, it would make sure that our view that we want to make 2D is there. We can control some outputs, what we want. And we can also show hidden lines. Now, hidden lines, and it shows a nice little diagram. Here are the dashed lines. And we can either hide them or we can keep them the same. So we can see with the technical view our hidden lines of what's going to show defined as a solid line and what's going to be a dashed line. So we're gonna actually keep the hidden lines on. And there's also a command called scene silhouette, which is really nice because when it creates this 2D line work, it's going to generate a polyline that's the boundary of it, which is another, it's like, yeah, that's a great thing too, because maybe I want to bring this into Illustrator and add a little silhouette to it. That works for me. So, okay, I like all this. This looks good. I'm going to click OK. And it's going to think, and it took pretty quick, took a second to do. And if we switch to our top view, there it is. There's our 2D drawing of that elevation. Now, when we do a Make 2D, it will automatically create a Make 2D layer and then a visible sublayer. Expand this. So it's going to say what's visible. It's going to create our scene silhouette. It's also going to do our visible curves, and it'll also break out our hidden curves, which is really nice. So that just makes things a lot easier for us later on. So let's say I don't want to, this view or this elevation is really important. I don't want to get rid of this elevation. And this part of it directly affects the assignment 1 because it can help you out when we set our views for a perspective. So let's say I really like this elevation. So what I'm going to do is I'm going to click this caret and I'm going to go to set view. And at the very bottom, there's named view. I'm going to click that. Right now, there's no named views in this file. I'm going to click this save as disk. I'm going to type in, we'll say east elevation. Click OK. What that did is that saved this view it saves the display style, saves everything about what makes this view. So later on, when I decide, okay, I actually messed up. All right, oops, it's way over here. I can always go back over, set view, and right when in the set view, we'll see this east elevation, and it snaps back right to that view. So this is great for when you start making diagrams, or you have this view of your building or object that you just really like, and you show it to the client loves it, but there's some changes. Well, you don't want to change the view, so you just save the view. You make the changes, and you go back, and you can just snap back to the view and re-export it. Now, this isn't, we won't deal with this in class because this deals with some more graphic side, but it is really helpful later on. But what we can do is we can export this 2D line work into it as an Illustrator file, and we can later on tweak it and start to make some pretty nice graphics or some pretty nice elevations with it. We also will, while we're doing that, we're going to, oh, that's loading. We're going to go to shaded view. We're going to turn our properties or display, just like our graphic standards. We're going to get this into a, more of a display like this. We could render this thing. So yeah, that's kind of cool. Let's do a great little display is Arctic. So we'll make this Arctic. We're going to just view capture file. We'll grab that. That works. That looks cool. Let's click OK. Save that. We're also in our top view. We're going to highlight this, and we're going to export this. We're going to export it as an Illustrator file. Saved, and it's going to give us some stuff. In this scenario, since my scale is so whacked out, and like 50 feet is 1 inch, I'm not going to do this preserved model because we can preserve it if this is all based off a very specific scale, like an 1/8 or 1/16. That's important to do. But this scale, in this example scale, is not too important. So we're just going to do a snapshot to current view. And we'll click OK. Saves as an Illustrator file. Can you guys, let's see. Yes. Share screen. Okay. So we're just going to File, Open. This may, some of the, from my experience from doing this, the coordinate system is pretty, oh, wow, okay. Sometimes when you export this, it may be way over here or way over there. This ended up being really nice. So actually, a lot of the line work came out pretty nice already on this. We can actually then go into layers, and once you know, there's all our Rhino layers. So we can start to just adjust these pretty quickly and make a nice graphic really quick. So there's our hidden layers. So we can just do our properties. Maybe switch this to something a little smaller. How about this? We'll do this as 0.25, and we'll get our visible layer. Let's expand this thing. Yeah, we want this guy to be 0.5. So, all right, so we have a little bit of a hierarchy to this. Then we can always throw our this guy in there. Bring that to the lower bottom. Make sure it's that. We'll lock everything. And we can start to create some pretty nice graphics. With Rhino and an Illustrator. Could be pretty sweet. Yeah, and then we can always save this as a JPEG or something. But just a nice little, again, you guys don't, I'm not requiring you guys to do this, but it's just a good tip. It's usually like if you see a lot of Bjark Angels diagrams, it's usually how they make it, or they'll use like a V-Ray or something really quick. But most of the time, that's how you see it. It's a great little technique that can help out. So we have a few more minutes. We can also, let's go back to another thing that we can do. Just gonna delete this. We're gonna make another surface. Change this. Since our browser can see it a little easier. Cool. Let's bring this over a little bit. Let's put these two. The only thing we can do is let's go back to let's draw a box on this. And we're going to split this again. Split it like that. We're going to hide this. Draw a little profile there. You know what? Maybe we'll make this a little more interesting. We're going to make this box tapered. We're going to split it. We're going to want to have a, say if we want to fix something about the surface or something, we can also do a sweep to on this surface as well. I'm going to delete this. And I can always use this as my profile and these as my edges, and it can see if this fixes up the surface. So let's select this rail. We'll select that as our second, and our cross sections here. Anyway, it's a nice little patch for the surface as well. We'll probably have to fix some of the tangencies on that because it didn't fit as well. So we can always refit it. But it's just something if we need to fix up something, or if we want to add, maybe this thing actually like peels up. Becomes some object. We can always do a sweep to. First rail, second. It becomes this little object that follows the curvature of this. It starts to peel up from there. So the nice thing is all this is controlled through just simple 3D curves, and then these really simple or these complex profiles can create even more complex surfaces really simply. So it's usually the workflow of this when you start to design things is just understanding your boundaries and understanding how far can this curve go, and it's actually to create these really complex forms. You start very simple. You start with these boundaries, and you start to create these little curves that are just accents. But then you can see by just connecting these curves, it can make this really complex and organic shape that can be really exciting. So it's to start this way, you don't start very complex. You just start very simple and simple big gestures, and that's how you can get these really complex forms. Some of the things like Zaha Hadid does, the gestures that they're making are actually really just big pen strokes, but with this software, it can create these highly complex forms. But the thing that controls it, it's just these just very gently, these just gentle curves. So just keep that in mind when we start to design into this and start to create some of these forms. It's really just think of just big picture things. And we got a little bit of time left, so I think we're just going to jump right into Grasshopper. Now, before we start, does anyone have any questions before we jump into Grasshopper?
John, for the assignment, the layers you gave, are those examples, or are those the specific 5 or 6 layers you want to see?
I would say do those. I would say use those specific layers.
Okay. So
can you go over that?
Yeah, like the columns, where would we put those?
Yeah, those. So, let me grab that.
And also the spandrel glass and some other stuff too.
Yes, actually, that's another thing. That there is no spandrel glass. So I lied. Why don't you guys do that as a, sorry, I did not really make this assignment all the way. So let's go into, because later on, because they actually have some metal panel on here. So use the layout of those. Actually open up that. Use the layout, the format of it, but not specifically, okay, this is metal panel 2, this is metal panel 1. There could just be one metal panel that covers up this entire thing. But just try to keep it as, okay, maybe 0_ metal panel 1, because there isn't a second metal panel. I believe this is all just one stainless steel or clear, and it looks like stainless steel. So it'd be like, all right, so we won't have metal panel 2. We would have clear glass. We don't have a spandrel. Mullions. We'll leave that one up to you. As long as things are formatted correct, they're at least have some logic. I guess the reason why I did mullions was because sometimes in 3D renderings that happens. I just try to prepare things as like into the real world of how people divide these models up. So yeah, really, you could probably have this in. You have your floor plates, which would be one layer. You would have your metal panel, and you could put your metal panel on the mullions if you wanted to. So you could actually make this thing up into 3 layers.
So I have a question about the floor plates and the metal panels as well. It looks like the floor, the metal panels are separate from the floor plates. So when we actually model this,
Yeah. So
you can see it on the bottom, the second floor, but you can't see them. It seems like they're hidden slightly, as you move up. How
how
detailed are we getting?
Not too detailed. It's very simple stuff. The floor plates, honestly, can just be so the mullions would be it's almost like taking the perimeter polyline of the floor plates, just and extrude that down 2 feet and cap that off. Now you probably want to offset that perimeter curve just a little bit. And maybe you offset that in about 6 inches because of this mullion, because of the horizontal mullions. So you have some thickness to it. So you don't have the metal panel and the floor edge competing with each other. But that's all it is just this like 2 foot thick floor edge. I'm not looking to see any structure. This is just to see some of the floor lines. Now, if you did the floor like 6 inches or 8 inches, that's fine too. It's just as long as you have something there as the floor. What I'm looking for is just there's a model for the floor, but these metal panels here, where's my mouse, are these things should be 2 feet deep. Hope that answers your question.
Yeah, no, it does. I just basically took a 2 foot swath and just cut right through the building as a floor plan. But
Yeah,
you're saying just separate that with another panel on the outside. I was just kind of wondering how detailed you wanted us to get with this.
You guys can get as detailed as you want. It's really just as long as you have the core dimensions of what I'm looking for and from the assignment, that's what I'm just going to grade. If you really want to get into, there's a panel here that's recessed and you can, but I'm not looking for that. You could have this this panel here, 2 feet, and then it returns right underneath this. You didn't model that lip. That's cool. This is just a simple massing model with just expressing the mullions. So a lot of times we do these massing model. This is like what we do give a lot of times when we start a project, we have to start understanding the context of things. We'll have people start to just generate some very simple geometric models. They're just really simple massing models just to start to have things, just to have it as a reference in our three-dimensional models. Also, when we do 3D renderings, it's just we give it a little bit of detail, not too much, so we can start to pick up the architecture. But it's mostly just for us to reference when we start to design. So I'm not looking for, so if you extrude these mullions all the way up, that's what I'm looking for. I won't be looking for all these little panelization. It's too detailed. I won't be, you can do it, but I won't be grading you on it.
Okay, cool, thanks.
Yeah. So any other questions? Also, FYI, since the dimensions, since we revised some of the dimensions, I pushed the due date back to January 30th. So if that's screwed up anyone, that they, hopefully this helps. Great.
And one last question. For this one, we're just exporting from Rhino into JPEG or PNG. We're not bringing into Illustrator and doing any line weight work.
No, all I'm looking for is all I'm looking for is the 3D model and yeah, and just one image of pick a view looking at the building in one image, and that one image just has to follow our that graphic standards. So that's just making the background white, turning off the ISO curves. You can put it into shaded view or Arctic view, but it's and and save the perspective view in the 3D Rhino. So just like what we did here with the east elevation, we can let's bring it back into perspective. We can set a view. We'll make the background white. We can either do it in shaded view or you can do it in Arctic view. And that's all I'm looking for is you guys to take that perspective, do a set view, named view, save it whatever one, anything that you like, and just do a view capture to file. And that JPEG and the Rhino file are the two things I'm looking for. And so like that. It would be helpful to have at least a ground plane. Just draw a really simple plane so you can get a little bit of a shadow or a little bit of ambient inclusion if you do the Arctic or shaded view. Not really shaded view, but yeah, draw a quick ground plane. That can help too. So yeah, that's anything else? Actually, shoot, I think we're actually going to be ruled out. Yeah, actually, it looks like we'll deal with Grasshopper next time, and we'll introduce assignment 2 in next meeting, and start. And with Grasshopper, that one is going to have Grasshopper has a really steep learning curve. Not to scare you guys off at all, but it's a different way of thinking. It is not just okay, I'm just going to move this over. You have to be very specific, and you're dealing with a lot of coordinates. I mean, the computer is stupid. I mean, we're the ones that control it. So in Grasshopper, it's looking for a very specific coordinates on things. But once we set up this framework and these coordinates, we can do some really powerful stuff and generate some really wild forms, and we can start to break things down and make things constructible. So it's a very powerful tool. It's just a different way of thinking about things. And like I said, it is something that is changing the industry. And it's a really exciting time right now, just because there's so many opportunities with this, and especially having Grasshopper as a visual programmer. You don't have to necessarily learn a programming language to program now. So we get to, the Grasshopper is built right into Rhino, so we're going to be referencing a lot of the same commands that we just used today, but we're gonna but it will show how these commands can be parametric, and we can generate multiple design iterations super quickly with this. So so I'm not just stuck with this one. I can continually manipulate it and change it and save them as all these different forms and show the client that, or 3D print them and have a bigger discovery on it or investigation on it. So, but great. Any questions before we go? Okay, well, great. Thanks, everyone. And yeah, just I'll send out a reminder that the first assignment is due January 30th. So, but yeah, email me if you have any questions or come across any issues. All right.
Okay, great. Thank you.
Yeah, no problem. Thanks, guys.
Thank you.
Thank you.
Have a good night.
Thank you.
Night.
Right.